welcome to Narayana online live digital class. It is given that two spheres whose radii are in the ratio 1:2 are moving with velocities in the ratio 3:4. If their densities are in the ratio 3:2, then the ratio of their kinetic energies. So kinetic energy, as every one of you are highly aware, it is half m1 v1 square by half m2 v2 square. So these two would now get cancelled. Now mass can be written as volume times density. This is volume, this v is volume and this v is velocity. Volume times density into v1 square by volume times density into v2 square. Now volume can be written as, here the bodies are spherical in shape, 4/3 pi r cube, 4/3 pi r1 cube, rho 1 into v1 square by 4/3 pi r2 cube into rho 2 into v2 square. These two would now get cancelled off over here. Now if we could consider the ratio of their kinetic energies are, r1 cube by r2 cube. Radii are in the ratio 1:2. So it is now 1/8. Okay, and velocities are in the ratio 3:4. That means it is 3 square is 9 by 16. And rho 1 by rho 2, densities are in the ratio 3:2. So it is 27 upon 8 2s are 16, 16 16s 256. It is 256. It is the ratio of the kinetic energies, right? Moving on to our next slide. In this slide it is given a large slab of mass 5 kg lies on a smooth horizontal surface with a block of mass 4 kg lying on the top of it. The coefficient of friction between the block and the slab is 0.25. If the block is pulled horizontally with a force of F equals to 6 Newton, then the work done by the force of friction on the slab between the instants t equals to 2 seconds to t equals to 3 seconds is dash. So a force of 6 Newton is applied onto it. So now let us try to consider the maximum static friction or the limiting friction between the blocks, which is mu times n. So now mu is equals to 1/4 into 4 into 10, which is now 4 and 4 gets cancelled, which is equals to 10 Newton, which is equals to 10 Newton here, right? Now let us now try to calculate as what is the, since the maximum frictional force, here we would try to say that the limiting friction is greater than that of the applied force over here. The applied force over here, the frictional force is equals to 6 Newton, as the static frictional force is a self-adjusting force. Now here, let us now try to consider the common acceleration with which both the blocks move. Now since the frictional force is, the maximum frictional force is greater when compared to the applied force, both the blocks they move together with common acceleration. So that is just nothing but the net force acting on the system by m1 plus m2. So that is now equals to, over here that would be equals to 6/9, which is equals to 2/3 meter per second square. Here every one of you need to understand that this frictional force acting on 4 kg block would be acting in this direction, and frictional force on the 5 kg block would be acting in this direction. When we would consider the net force, these two forces they get cancelled off. It is the 6 Newton we have been considering. So now distance covered by the body during 2 seconds is equals to half. Acceleration is 2/3 into 2 square. So this 2 and this 2 gets cancelled. which is 4 upon 3 meters, right? So S3 is now equals to half 2 upon 3 into 3 square. So this 3 and this 3 gets cancelled, 2 and 2 gets cancelled, which is equals to 3 meters over here. So now here we would try to consider the displacement as S3 minus S2. So which is now equals to 3 minus 4 upon 3. So it is 9 minus 4 is 5 upon 3 over here. So work done by the force of friction on the 5 kg block over here is now F bar dot S bar over here, which is M into A into S. Mass over here is 5k, mass over here is equals to 5 kgs over here into acceleration over here is equals to 2 upon 3 into the displacement is equals to 5 upon 3. So it is 25 to 50 by 9 here, 50 by 9. Okay, so this is what is the work done. 50 by 9 joules is the what is the work done. So now when we are trying to consider 50 by 9 upon simplification, it is 5.55 joules. Okay, right, which is matching with our second option. Moving on to our next slide. A block of mass M is suspended by a light thread from an elevator. The elevator is accelerating upward with uniform acceleration A. Work done during t seconds by the tension in this thread. So tension would be acting vertically upwards over here. Okay, and the displacement would also be along the same direction. So work done by the tension in the string is now equals to T bar dot S bar. So it is Ts cos 0 here. So when the elevator is accelerating upwards, tension is m into g plus a and distance is equals to half at square here. So considering that, if you could say it is m by 2 into g plus a into at square. This is what is the work done by the tension. This is what is the work done by tension here. Right? So which is matching with our first option. Right. Moving on to the other slide, it is given that if 250 joules of work is done in sliding a 5 kg block up an inclined plane of height 4 meters, work done against friction is. Now over here we need to understand that work done against the friction is done by the applied force. Work is done by applied force. Work is done by the applied force and work is done by the gravitational force. Work is done by the gravitational force. Right. So now this is m into the acceleration due to gravity acts in the downward direction, and with our given data it is equals to 250 joules of work is done by the applied force. So it is 250 joules of work is done by the external force. It is mg into h over here, the work done. Okay, so it is 250 minus mass of the block is 5, g is 10 into its height is 4 over here. So it is now equals to 50 joules is the answer here, which is matching with our first option. Moving on to our next slide, it is given that a particle of mass 2 kg along a straight line with velocity v equals to a into alpha root x, where maybe you can say alpha or A is a constant over here. Okay, you say it is alpha. The work done by the net force during the displacement of the particle from x equals to 0 to x equals to 4 meters over here. Right. So now here we would try to say that work done would be equals to change in kinetic energy. This is according to work energy theorem. Work energy theorem. Work energy theorem. Work done by a constant force is equals to change in its kinetic energy. So it is half mv square minus half mu square. Right. So which is half m into v square over here is alpha root x whole square minus half, this is final, I mean to say it is half m alpha root x, this is initial whole square. So that is just nothing but half m into alpha square x final minus half m into alpha square into x initial. Now here if you could consider, this is now equals to half m alpha square into x final is equals to 4 meters minus half m alpha square into x initial is 0. So which is now equals to 2m alpha square. Okay, mass of the block is equals to 2 kgs, so it is 2 into 2 into alpha square. So which is equals to 4 alpha square, which is matching with our third option. Right? Hope every one of you, it is all clear to you, and thank you all.